of taking elements, we are going to do the rod shape still, and I also will try to fit in the disc video in 10 minutes. So we are going to do the next type of ways they can ask the question. So this is a question from JEE Mains. Wait a second. JEE Main 2024. It's a good question, I will say, like from gravitation again. So the question is, a metal uniform mass density rod having density some lambda, having length and mass is bent to a semicircular arc. Basically, a rod is taken and it has been bent into a semicircular arc. Okay, we understood until this part. So they are asking that at the center of the arc there is some unit mass m. They are asking the gravitational force between this particle and that wire. So how are we going to do this one? We are still going to do this in the way of taking elements. I'll show you. Here this is theta, this is d theta, very small angle, right? So yes, and this part we are taking that strip as r into d theta, as we all know L equal to r theta. I hope you all are aware of this basic rule. So we are taking that, and this is also, yep, that's what we are taking, that strip. We all know that lambda is equal to mass per unit length. Here we are taking that small mass and integrating it to be able to get the force that we require for this entire thing, system. So lambda is equal to dm by dl. We all are aware of this. And dm is equal to lambda into dl. What is dl? dl is nothing but r into d theta, as this is the variable. Yep. So dm is basically lambda into r into d theta. We got that. We know that the gravitation force is F equal to gm into dm by r square, as the distance is basically r. This makes sense, I suppose. And one more thing, guys, the force can act like this, like this, like this, like this, blah 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 blah, right? Yeah. So how is the force acting? This is very important. Let's consider this as some theta. So the force acts like this. This is F sine theta, this is F cos theta, and similarly it's going to act F cos theta over here. So the net horizontal force is equal to 0, and the net vertical force is equal to F sine theta. But we want the entire thing, so it is we are going to have to integrate the force as well, because that thing is not enough. Yeah, we just integrate it, and integrate df is nothing but, what is df vertical? Sorry guys about this, sorry, I just got a little bit confused. df vertical is g and df sine theta, remember? Yeah. So gm into dm by r square into sine theta, and we know that dm is lambda r into d theta. So if we just substitute that thing over there, gm into lambda into r into d theta sine theta by r square. I'm just going to cancel this. The F vertical is just gm, and lambda is nothing but mass by length. R is nothing but, what is R? R is L equal to R, and the theta that it is covering is pi, 180 degrees. 180 degrees is nothing but pi. So R equal to L by pi. We all agree to that. So L by pi, and sine theta into d theta, as it is over there. So now if we integrate that, so where to where do we integrate that? From 0 to pi degrees. So 0 to pi, and F vertical is the only force that is acting. It is equal to gmm L square pi. And what is the integration of sine theta from 0 to pi? Here is a shortcut. This is 0, this is basically pi. For every mountain, let's just think of this as mountain, the area is 2 units. So the 2 units, or else we can just normally integrate it. and I think you all are aware of that. So gm by L square is our answer. I think the explanation was a little bit too crappy. Let me re-explain it again. Basically, for these type of quantities, why we are using the element properties is that we have to consider the ways that the force is acting. We have to consider this whole mass, not just at one particular place. That is why we are taking it as small strip, as I have shown it over here, and from that small strip we are integrating it to get the basically the whole system. That is why we took dm mass. So to show that the force is over here, and we are integrating it to be able to get the entire thing. That's it. That's the basic concept. And the force is going to act on every single particle. If we resolve it, it is going to be horizontal and vertical, and only the vertical force is acting. That is why we did the process that we have done. That's the question. I think this is a good question. It's a beautiful question in my opinion. And let's also get the basics for disk. Yep, very bad drawing, I do know that. So this is a disk. For disk, the density is areal density sigma, which is mass per area. That is the density for disk system. In this disk system, we are going to consider at some point, we are just going to basically take rings, guys. Basically take rings and integrate that to be able to get the whole surface. So if I consider this small place and took this ring, the distance is r, some variable distance which I am considering it as r. And how do we do this? We have to consider small places, right? Sigma equal to dm by dA, dm equal to sigma into dA, and we know that area is equal to basically pi r square, and what is dA, which is basically 2 pi r into dr. Yeah, just differentiate it. I think you all have understood this part. At that point, we are just taking a ring, and that is a small place. That is why we are taking it as some variable distance r. Like this could be some variable again. This is capital R, total thing. We have to integrate it from basically 0 to complete thing, which is r. Let's do a question based on that. In this question, this is from rotational mechanics, moment of inertia question. Sigma of r. So basically they are asking us to be able to find moment of inertia of standard disk, basically standard thing that they want, and they give that the density, areal density as a plus br, and they are asking us to find the moment of inertia of that disk, and the radius they have given is a. They have given some a radius. Okay, so I'm taking this strip. This is a disk. I'm going to show it like this. Yeah, blah, blah, blah. So this is a disk, and the distance is some r. The dA is 2 pi r into dr, and moment of inertia is nothing but I equal to integration of r square into dm. You are all aware of this. And dm is basically sigma into 2 pi r into dr. I'm just going to put it over there. So I equal to integration of sigma 2 pi r into r square into dr. I'm going to bring the constants outside. 2 pi. What is sigma? We got that the sigma is a plus br, and this is some r cube into dr. Just integrating it is fine. And from where to where we have to integrate it, guys? We have to integrate from 0 to a, basically covering the entire disk. 0 to a r cube plus b r power 4 into dr. Now we are just going to integrate it. 2 pi, and this is a r power 4 by 4, basic integration. 0 to a plus b r power 5 by 5, and again 0 to a. We are going to find it soon. 2 pi a power 4 by 4 plus b a power 5 by 5. Let's take just a power 4 common. We are going to get that option, a by 4 plus ab by 5. This is the question that has been asked in JEE Mains. What year? 2020. JEE 2020. That is how we do the integration and the taking elements part for the disk. I hope you all understand. Have a blessed